Well, it is 12:39, so I'll start by covering the logistics for people that are joining. Probably tired of hearing this by now, but you're in a Zoom webinar, not a Zoom room, traditional room, so you won't have access to your mic or camera. But that said, you can interact through the chat box and are highly encouraged to. So you just click that little chat button at the bottom, type in your questions. We're going to save all of them till the end. And if we don't get to all the questions, we'll answer them and put them up on the website later. That'll go out with the recordings. Last bit is when you're typing in the chat box, make sure that you hit that little drop down box and click everyone, because it defaults to just messaging the hosts and panelists. And that way everyone can see the questions that you're asking. So with that, thank you everybody for joining. Today we have Darren McAvoy, from Utah Extension. I feel bad. Is it Utah State? Utah State Extension, of course.
Utah State University Forestry Extension.
Yes, yeah. To talk biochar, which is a really exciting and interesting new field. I won't give Darren's bio. I'll let him do that because he knows it better than me, but I'll turn it over to you, Darren.
Great. Thank you so much. Really appreciate the invitation and all the setup, Patrick and team. Darren McAvoy. I'm an extension forester at Utah State University. My background that's relevant to you, I think, is that I was, before being an extension agent for extension forester these last 20 some years, I was formerly a consulting forester in northern Idaho out of Sandpoint, helping small landowners such as yourselves set up timber sales and write management plans, that sort of thing. Did a lot of burning with them and a lot of wildfire suppression with inland forest management then. Prior to that, I was on the Flathead Hotshot crew. I'm actually a veteran of the Yellowstone fires in 1988, and I studied forestry at Colorado State University. And hopefully today's presentation, well, it's my attempt to sort of combine all those different points of view and backgrounds into this current project. And that background greatly informs what and drives what I do today. Here in this first photo, we're in Moab, Utah, with Red Rock in the background. Colorado River runs between my biochar kiln there and the Red Rock in the background. We're pyrolyzing Russian olive here along the Colorado River on private land, just downstream from Moab. I represent the Utah Biomass Resources Group. Our partners are super important to us. I don't do anything without partners. The Southern Rockies Fire Science Network, the Utah Department of Natural Resources, Forest Service, Bureau of Land Management, Go Biochar, and Evergreen Soils, all important partners to bring in, and many others that I can't mention, don't have time to mention, other colleagues, and that brought a lot of this information, helped me bring a lot of this information to you here today. It was in 2009 when I was asked by the Forest Service and the Bureau of Land Management to create a biomass group for Utah to find value for low value fuels and wood. And I've been burning piles for most of my career. I'm burning this pile in New Mexico just a couple of years ago. These piles actually sat on this ranch for 6 years before they were able to be burned, with restrictions from air quality and fire danger and availability of personnel. It just takes that long sometimes. And it's not really the best thing to have this material sitting on the landscape as hazardous fuels for that period of time. And from the first piles I burned up in Montana in the 1980s, it was just, and I think many of you maybe feel this as well when you're burning piles. What a waste. Maybe there's something different we can do with that. And today I'm providing perhaps an idea of an alternative to typical pile burning. I don't think we're ever going to really replace pile burning, but I think on the edges and sensitive areas, this approach makes sense. Part of our goals, of course, are reducing hazardous fuels. That's how I tend to really sort of sell this program. And but increasingly, I talk more about carbon over time and improving firefighter safety, both pretty important to me. increasingly important is that making biochar is a way to preserve the carbon in wood. That pile that I was burning in a couple slides ago, if we let that sit on the landscape, it'll all go up in carbon dioxide. It will, if we burn it openly. With this method, we can preserve perhaps a third of the carbon that's in there, that prevent all that carbon from going into the atmosphere. And that's a direct way to fight climate change by that's how we take carbon out of the atmosphere, by preventing it by going up into the atmosphere. Biochar, when applied to soil, is super durable. It has a half-life approaching 1,000 years. So it's going to be there for a while, doing good things. And I see it as just a simple means of adding carbon to the soil. To my knowledge, there's no other way I can teach, or anybody can do simply in the backyard, on the farm, on the ranch, out in the forest. You can sequester carbon. So that's what part of what today's talk is all about. How biochar is made, briefly, it's called pyrolysis. This is separation by fire, technically thermochemical decomposition. You're going to see a lot of fire in my slides today, but the pyrolysis is actually going on deep inside a log, or deep inside the kilns that I'll be sharing with you today, where the oxygen is limited and the temperatures are in that 400 to 600 degrees Celsius range. What biochar does is it absorbs nutrients and water, makes them available to plants. It changes soil structure. It's kind of like putting a million sponges in your soil and adding all these nooks and crannies, and that makes a home for microbial activity and increases the microbial ecosystem and the microbial ecosystem food web. It also increases soil water holding capacity. Depending on the type of soil, it can be between 18,000 and 25,000 gallons per acre if you add perhaps 10 tons per acre of biochar, which is not a tremendous amount necessarily. It's kind of a standard prescription. And so I see it, especially as a Utah resident and employee of the state of Utah, as a way to almost turn some of our dry lands into reservoirs by adding this many gallons per acre of water holding capacity. And since I'm a professor, I'm allowed to provide academic examples or points of view, and that's what this is here, this particular slide. There is no value chain or business model at this point that accounts for all the potential value stations of biochar, and that's partly what makes it tough to pay for at this point. But people are definitely making a living from making biochar in some places. And these 5 steps I suggest, or places, value locations for biochar, if we could find a model to add them all up and one person gets all the value from each of these stations, and it starts to really make a lot more sense. And that includes, we're reducing hazardous waste, and so we're preventing fires by doing this, reducing hazardous fuels. We're absorbing nutrients and moisture, in some places unwanted nutrients, such as next to a water treatment plant, between a water treatment plant and a wetland, say. We can use biochar as a livestock feed amendment, and I'll talk more about that later in my presentation. Actually, when we do that, the animals charge the char. They add nutrients to the char while it's in their gut, and they pass it out onto the land, and that's one way we can put biochar out on the land. And there's some caveats with that I'll discuss later. It improves soil long-term productivity, which is usually always a good thing. Anytime we put carbon in the soil, it's good for the soil, typically speaking. And as I mentioned, it's a way to sequester carbon. So here's 5 potential value stations, if you will, for biochar. I wanted to point out early that it can be characterized. It's not just mysterious. We sent it to a lab. I happen to use this lab in California mostly, and they have their own they're used to handling biochar. Part of the reason I send it to them. And the number that I think is most interesting here is the third one down on the left, the organic carbon. And this is biochar that I made in southern Idaho from Russian olive along the Bear River, and with just simple kilns, very simple methods, and that I'm sharing with you today. And it's 86% organic carbon. So almost all the carbon is preserved in this material. It's almost pure carbon. And so I'm really pleased with that number, that we can, with simple means, that we can produce such a high value, high quality biochar. I didn't start off just burning stuff in boxes. I want you to know that. Started off with more high-tech approaches, and I'm going to share a few slides of that background with you so you know how I got to where I'm at. And so I've worked quite a bit with these high-tech biochar kilns, and one of the advantages of them is that they make super high carbon, 90% plus. They can make that high of a carbon content material. And they have a consistent piece size, like I'm showing here. And that is because we have to chip all the wood that goes into these high-tech machines. It often has to be to a 3/8 inch standard chip, which has its own expense and challenge. I actually got started into the biochar world with this gasifier. It's a mobile gasification unit we called the Dragon Wagon, and put it together in 2011 with a USU extension grant, and toured it around this part of the West, and actually hosted Utah's first ever and only ever wood-fired concert in Main Street in Beaver, Utah, in about 2013 with a country rock band. So it produces enough power for about 2 homes or a country rock band. And but it's very small scale. With this, in this machine that you see in front of you, I actually went to Lowe's and just bought a propane generator. We use the machine to clean up the wood and cook the wood at this super high temperature, 800 degrees Celsius. We run it through some filters, and that propane generator make enough power for, as I said, about 2 homes. But I found this to be pretty impractical. It took all the effort and all the concentration of this very qualified individual to keep the thing running. It's kind of hoping a farmer or rancher could have it in a remote place, put a barrel of wood chips on it, run it for 8 hours, come back 8 hours later, and just keep doing that. But it wasn't that practical, but it was helpful for getting us started, and we learned a lot. As we were working on that, we got some help from another company called Amaron Energy. And over in the other corner of their shop, as we're working on our gasifier, was this machine we knew nothing about at the time. We came to learn a lot about it. This is a pyrolysis machine, a rotary kiln. So inside of this housing that you see is a 7-inch diameter stainless steel tube. That's the length of that housing, about 7 feet. And it's constantly turning and superheated with jets from gas jets from the outside. So it holds this high temperature, 400 to 600 degrees Celsius. So in the previous example with gasification, all of the wood, all the material turns, almost all of it turns into a gas. A little bit comes out as biochar. At these lower temperatures in pyrolysis with these high-tech machines, we're making 3 different products: a biochar, a bio-oil, and then a syngas or synthesis gas. And that's similar to propane, like what we were running with the Dragon Wagon. And we can just run that through the machine and make it more closer to self-perpetual with that approach. But here it is bolted to the floor of a shop in Salt Lake City. And especially in Utah, our wood resources are so diffuse. So it needed to be in the woods. So I was able to take some money from the Forest Service and support from the Bureau of Land Management and make it mobile. And here we are in Bingen, Washington, up in your neck of the woods in 2013. And the Washington DNR hosted a mobile pyrolysis cook-off, if you will. And we were honored to be part of that and compete, and even more honored to sort of take the prize, to win the competition for making the most and the highest quality biochar amongst the other people there. So we were really excited about this and going down that road. And this allowed us to get another grant called the Sun Grant to scale this up. The size of this machine, so the machine I showed you in the previous picture is mounted inside of this blue trailer. And I told you how big that tube was, 7-inch diameter. So that will take about 1/2 ton of input per day. So maybe a big pickup load. This is the guts of the newer, more scaled up machine. In 2014, it was new with this Sun Grant. And this is a 24-inch diameter stainless steel tube that's 15 feet long. That will be the guts of a bigger pyrolysis, mobile pyrolysis machine. And this will take 20 tons a day, and a truckload, excuse me, a loaded truck log, a loaded log truck is about 24 tons. And so this is approaching that amount of wood. This machine is excellent in woods processing of material into the bio oil and the biochar and the syngas, as I mentioned. We're on a 40-day run in the Nevada desert working on juniper here in this photograph. And around 2014, when the price of oil went from $100 a barrel to $30 a barrel, the value of our oil we lost all value for that oil, and it became actually a liability for us. And we started burning it off in these incinerators. You see these white boxes on the right side of the pyrolysis machine. And so I want to say that it's really important to have high-end machines like this to make what we call designer biochars, more sophisticated, precise biochars. But at the time, when price of oil went down so low and our value of our oil was down so low, we really started focusing on the biochar, and it sort of forced me to look for less expensive, more accessible ways to make biochar, accessible to landowners such as yourselves. This is John Webster of Go Biochar. He owns that machine now. I'm really pleased that he purchased that machine a year or two ago that I've showed you in the previous photos, and he's producing it under this name in Salt Lake City. So we still have available to us this high-end biochar material, but there's also room in this market, I believe, for a low-end material, more accessible thing, and even outside of markets, just for landowners such as yourself to be able to make biochar on their land. Here, John is lighting for us one of my big box kilns I'll show you more about in a little while. One of the big downsides that I see from having the high-end machines is that, as I said, we have to process the wood. Yeah, handling feedstock is expensive, and to get it down to a small chip size was really expensive. In that Nevada example I showed you, it was actually more expensive to chip the wood than it was to pyrolyze it, which didn't really make that much sense to me. And that was one more thing that made me look for a lower tech method with less feedstock handling costs. And in 2016, I went to a biochar conference in Corvallis, Oregon, and got introduced by Kelpie Wilson, one of the presenters there. These kilns are called Oregon kilns, or flame cap kilns sometimes. I often call them just small kilns. And it's just a simple metal box. And I was fortunate in 2017 to be able to get a USU extension grant to have Kelpie come to Utah with 4 of these kilns that she left for us and give us a one-day workshop to kind of get us up and running. Kelpie is the owner of Wilson Biochar in Cave Junction, Oregon, and currently still a very important partner of mine. And the process I wanted to share with you, this is actually at our first workshop that Kelpie was hosting and helping us to put on. I guess I was the host and Kelpie was the instructor at that time. And we're actually at the Utah State Prison right in Draper, Utah, super urban area. The wind was blowing about 40 this day. We have these wind screens for them. This is about the only time I've really used the wind screens. But the process, important part of the process, is we start with kindling with small fuels up on top, and we top light the kiln. That's a critical part of the process. Underneath that pile of smaller fuels, you could have much larger fuels. Here in Utah, where things are so dry, it's easy to have 10-inch diameter logs. This is aspen and Doug fir mix here in a active thinning project that I'm showing you. And we create a rick of logs, that is to say a crisscross pattern. So there's a lot of oxygen down in the kiln to get started with. But the sides and the bottom of the kiln are all sealed, so no oxygen will enter it once we get the flames going across the top, or a limited amount of oxygen. And here's the kiln going at sort of full blast, and takes a little stirring. It's worth mentioning, safety equipment is important for this. I would really avoid polyester clothing when I'm doing this kind of work. You don't have, this firefighter, of course, has Nomex clothing. That's not absolutely necessary. I feel pretty comfortable doing this just with cotton clothing or wool clothing. So I just try to avoid the polyester. It melts to your skin. You don't want that. Hard hat, safety glasses, leather gloves are critical. Leather boots are a good idea. Pretty much common sense safety things when you're dealing with fire. you get it going, you let it cook. And you heard me say these are flame cap kilns. So we're looking down into the flame cap. And so that happens across the top of the kiln as it gets going, and it consumes most of those combustibles as they come up, resulting in a clean burn. We add fuels as the fire allows, just like tending a campfire. If you put on too much on a campfire, it's just going to smother it. If you put on too little, it's going to burn out. So again, a common sense approach. In this example, we're in southern Utah, south of Moab, Blanding, San Juan County, really dry place, really dry fuels. Here we're adding perhaps 6 to 8, maybe even 10 times the volume of the kiln before we stop the process. And I'll show you more about that now here in a second. But in super dry conditions, you can consume perhaps 10 times the volume of the kiln at once. And in super wet conditions, it might be closer to 4 times the volume of the kiln. And so we're looking for a point when the kiln is close to full of coals, or you're done with the fuel surrounding the kiln, and the flames drop from flaming combustion to a glowing combustion. And that's what we're seeing in this kiln here, with the example of this one log on the top. And you'll always have a couple of extra logs that are different size or burning at a different rate. Tend to just pick those out and throw them either in the next kiln, or perhaps after they've cooled, spread them out on the landscape for coarse woody debris, or they can be used for hugelkultur, an alternative gardening method where you bury logs and grow vegetables and such on top of these mounds. Critical part of the process is quenching, so it does require water for this. It is possible to dry quench, but it takes a lot more work, and I'm not going to talk a lot about that, but that is possible. I tend to use water, bring in a tanker, a engine or something, sometimes pumped straight out of a creek, and quench the water or quench the kiln. These smaller kilns take about 70 gallons of water to quench. And you can see that's washing a lot of the ash off. So biochar is not ash, it's a completely different material. We don't produce a lot of ash in this, but a little bit. Most of it tends to get washed off during the quenching process. A few strong backs or possibly an ATV or something could be used to tip the kiln, and they can be fairly heavy at this point. The kilns themselves weigh about 200 pounds when they're empty and dry. So we tip the kiln out and pull out our biochar out of that. We always want to make sure we have a fire line around this area first. And another example of how I'll show several examples where we're looking straight across the top of a kiln, and you can see the forest or the mountains on the other side clearly, just showing that it's a pretty clean burn that's going on. Example of an exception to that, this is on a ranch just south of Logan, Utah. We had a big blowdown 2 years ago in the fall, and just 2 weeks later, very green spruce where we're burning it. And it tends to make a smokier burn when you do green material. My colleague Ken Carloni from Oregon, who's helped inform a lot of my work here, his experience is that he can green chain, or he can hot log, however you want to call it, use green material as he's logging up to 4-inch diameter in these kilns and larger kilns, and it will consume that efficiently. And this smoke will die down after we just added a bunch of fuels, but it can be smoky at times, but it usually is not. The real value of these small kilns is their mobility and accessibility. It takes a few people to move them around, can be moved around with a pickup, and you can get into tighter places and places where you can't drive in bigger pieces of equipment. They're stackable. I can get 4 or 6 of them on a trailer, lift them off. Have these eyelets for moving them around. You can put a sausage in those eyelets when they're operating, and it's a culinary device. And I've had even smaller kilns made. The ones I've been showing you are 5 foot by 5 foot on top. This one is 4 foot by 4 foot. I had a few of them specially made so they'd slide right in the back of my pickup. I could drive across Wyoming, as I did here in the dead of winter, to give a presentation, a workshop for the city of Longmont. And a lot of interest in Colorado, several partners developing there, where I'm going to use small and large box kilns for demonstrations there coming up. And wanted to point out these small kilns, one of their shining points is that they're great teaching and learning and demonstration tools. I like that about them. They're safe, they're easy, they're accessible, but they're tiny. They're so small. And when I first got into this and looked at these small kilns, frankly, I was kind of rolling my eyes at the size of the scale. It just seems so small, but I am a believer in baby steps and moving in the right direction with small incremental steps. And so I looked at it from that point of view, that it's a good baby step to learn the process. And it was very useful to me. It was an important part of the process to get where I am today with machines and kilns more like this. This is what I'm developing. This is, I call the big box kiln approach. In 2019, I was fortunate to get a Utah Public Lands Initiative grant to develop this, and partnered with the Forest Service and the BLM and others to figure out if we can do this. Of course, rednecks have been burning stuff in dumpsters for years and years. It's nothing new, but of course, the process that I'm sharing with you makes it very much different. And I'll share with you some of the nuances of these kilns that make them different from just a dumpster. This was my first big box kiln I made in 2019 with this grant here in Logan and the Logan Ranger District. The Uinta-Wasatch Cache National Forest was awesome to work with me to help me get started on this. Here we're working in Providence Canyon, just south of where I live in Logan, in juniper fuels. It was a wildlife habitat improvement project. Up there on the right, on the background, you can see the piles that we're working with, and fairly small fuels in this. And I've come to learn that this kiln is perhaps too big for these fuels. I think it could have applied better, perhaps up in Washington, and super heavy fuels, but at 3,000 pounds, it kind of requires a great big 34,000 pound excavator to move it around, which comes with its own low boy and operator and scheduling headaches and costs. And in this kiln, at 6 foot tall, I found was too tall. It's hard for the firefighters to see down into. You can't see what's going down in there. And it's also a single wall construction. And I've improved upon that with a double wall construction. I'm going to show you here. So the next year, I developed a second set of kilns, and this is more the design that I've made more of. Made and helped make 3 or 4 of these now, and I call this the BB12 because it's a big box, 12 foot long. It's 6 foot wide and only 4 foot tall, so easy for me to lean over and light and see down into. It's, as you can see on the edges, it's double wall construction. There's a little gap there, and that insulation, that air insulation, helps protect the operators, the firefighters, and the equipment from the heat coming off the kiln, and creates more even heat distribution down inside the kiln, so we have better biochar production. And these weigh 2,000 pounds, and my intention was to sort of design this down for an F-150, that a typical pickup that anybody has and can move this around on a trailer. And one of the big advantages here is that it only requires a mini excavator to move around or to load. It can be loaded by hand once it's in place and tended by hand. It can't be tipped by hand. Need an excavator or some piece of machinery to do that. But anybody can rent an excavator, a Mini X, at most any rental shop, and you don't need special training. Most folks can kind of figure that out. Several of my demonstrations and workshops now, I've had landowners working there, who have gone to rent their own Mini X to do it, or firefighters, state firefighters have been running them, and federal firefighters in some cases as well. Easy for me to say. I wanted to point out the Bureau of Land Management owns 2 BB12s now. This is one for the Moab field office of the BLM, and more recently, the Dillon, Montana field office of the BLM has built their own. Again, looking across that flame cap and how it's consuming almost all the smoke. You can see the mountains there on the other side. I work with the air quality folks, Paul Corrigan with the state of Utah, and he set up this monitoring device next to my big box kiln at my first demonstration, and it showed no different air quality than a similar device that was 10 miles away. So no obvious impact to air quality. Kind of working with perhaps I intend to work with legislators and others and get more data on this sort of thing so we can get more of an exception to pile burning. Right now, this is considered essentially pile burning. So we have to jump through all those same hoops as you do when you're burning piles. But we're working to change that. Looking across our flame cap one more time, just wanted to point out when you quench, especially this is the example of the BB12. It's when just about now in the next few minutes, we see a little bit of flaming combustion here. It's about to die down to glowing combustion. But more practically, we often will quench when the kiln is full. This kiln is pretty close to full. Or even most practically, what I find is that we do 2 shifts in a day. We come in the morning, load the kiln, have a full burn, quench, dump just before lunch, take a little break, do the same process. So at the end of shift, we've quenched and we can walk away with no fire going overnight. We are tipping the BB12, actually the BB16, excuse me. So I see this as perhaps the most kind of tricky and dangerous part of it. These chains often will use straps. I find straps just a little less cumbersome. They have pretty nice straps these days that will handle this kind of weight, and I find them a little less cumbersome. Once we get these kilns going, we can often move them around. You can see there's one in the background. I'm moving operating 2 on this site here in the Uinta-Wasatch Cache and the Heber-Camas Ranger District. And once you have one going, if you ran out of fuels at that spot and it's upright, you can just drag it with an excavator or a pickup. I drag them actually burning with my Tacoma sometimes. It's worth saying, and there's no question that it's harder than burning piles. It's more expensive than burning piles. It takes more labor than burning piles, but it offers some advantages to burning piles. And it can be done concurrently, which is what we're doing here in this photo. And the main advantage more and more that I see from burning piles is that it preserves the carbon. At that Heber-Camas Ranger District, it was a salvage sale, and the firefighters and the loggers and the firewood folks had sort of taken what they wanted from these piles, and the forest asked us to clean up the rest. And so it brings me to a point, it can be sort of a sliding scale on what's more important for you and as far as how you operate these kilns. Is it just fuels reduction? If so, you don't have to quench near as much. You just keep loading the things and maybe let them burn overnight. Here, we're processing 30-inch diameter logs, and one of the nights it was cold and snowing, so we felt pretty safe doing it. We stacked them full of 30-inch logs at night, left for the night, came back in the morning, and we had a partial bin of biochar ready to be quenched in the morning. Actually burned most of them up. There wasn't much char left. So, but if you're more interested in the biochar production, you could slide that scale towards that side by quenching more frequently and trying to preserve that char. We can make biochar, and we did, and just fine from this large diameter material. But if biochar production is the most important thing, we find that more consistent piece sizes, perhaps 7 to 10-inch diameters, is ideal for biochar production. I worried a lot going into this project. Am I going to burn up excavators? Is this going to cost me a lot of money? Do I need to take personal loans or liability insurance about this? But I'm fortunate that I've had great operators working the excavators at all my workshops and projects, and they just monitor it. They get out every once in a while, touch the excavator, make sure it's not too hot. The hoses aren't too hot. I really expected to burn up hoses when we're working right in the fire like this, but I guess it's like how you can bring your bare finger over a candle without getting burned. If you just don't spend that much time in there, it's not that bad. We tend to use drip torches for lighting our kilns, but you can use a propane torch, just some newspaper and kindling to get it going. But again, a top light is an important part of the process. Here you can see the eyelets in the kiln for moving it around. I also have fork pockets in the kilns for moving it with large forklifts. Always worth talking about fire safety. We tend to construct a fire line around these kilns before we move them, or before we operate them. They don't throw near as many embers as a pile will, partly because the wind protection, and it's just an enclosed thing. But Embers can more typically mechanically kick out of them more than by wind. So you have to be very careful, chase down embers to prevent spot fires. You want always to have a charged hose, a hose full of water ready to go when you're operating. Here we're operating with mostly, you can see a fire engine there, so we had it as backup, but we're mostly just quenching from the creek that was flowing nearby out of that culvert that you see in the background. And always confirm that the fire is extinguished before you walk away. It's a firefighter trick or tool or standard is called cold trailing, where you touch pretty much every square inch of material with your bare hands. Eventually, perhaps you start with gloved hands, and if it's too hot to hold your gloved hand in there, then you keep stirring it and quenching it. And eventually you start with the back of your bare hand so you don't burn your palm, but eventually you'll use your palm and just run through every square inch of that material, just so you know that it's out. There's no other way to confirm that a fire is out. As a firefighter, and I got assigned a lightning strike up on top of a mountain that was a quarter acre or something, I would personally touch every square inch of that I could get to my hands on before I felt comfortable walking away saying, yes, that fire is out. I want to share some other kilns and approaches with you so you have a better feel for the sort of variety of things that can be done. This Kelpie Wilson with Wilson Biochar Associates has these available on her website for sale. They call them the Deluxe Ring of Fire Kiln. Deluxe because it's a double-walled kiln. And this one, it's more modular than the kilns that I work with. So it can be bolted apart. You don't need a great big truck. You can put this in the back of your pickup. We work with some people who put them on sort of power wheelbarrows and move them piece at a time into the woods when they're working away from roads. So it's a useful and popular approach these days. This one has no bottom, which makes it a lot lighter, but you have to dig that into the ground, which can be a little bit more labor. Just want to point out this excuse me, to my knowledge, this is the biggest biochar producer in my region in Berthoud, Colorado. I have to be coming back from that workshop in Longmont that I showed photos of earlier and stopped to visit. This is James Gaspard's operation. And he's got these batch biochar kilns just north of Denver. And I think he doubled the number of kilns that he had since I was there. And there was trucks of wood coming in and trucks of biochar going out the whole time I was there visiting. So just as an example or a point that there are profitable businesses possible from this approach. And kilns can be improvised. You don't have to have the kind of kiln that I've been talking about. Here is, we're in Boulder, Utah, and I was invited to come give a biochar demonstration for their annual harvest festival. And my kilns were busy up on the mountain. I'd love to come work with you, but I don't have kilns available. What do you have available that we can use? And what can we improvise? And they had this old cattle watering trough. And initially, when I went to the big box approach, I thought I was going to be reusing old dumpsters and oil containers and things like that, or things like this, but they often have paint on them or galvanized material on them. And as a public employee, I'm not comfortable exposing my colleagues to that sort of thing, or workshop participants. That makes no sense for me. It's part of the reason I go with originally made kilns. But if I was a landowner way back in the back 40, you might have a little bit more flexibility for that sort of thing. And so I encourage you to consider using materials that you might already have on hand to repurpose things for that sort of thing, with that safety in mind. Just the size of kilns can vary greatly. Here's an example of a non-purpose built kiln. This is just a Lowe's or Home Depot style fire pit that my friend and colleague uses in his backyard for making char for his garden. In the smallest scale that I am sort of aware of and work with, just want to point out, it can go way tiny. And this is a landowner, a rancher near Camas that I work with. I do big box workshops on his property, but he kind of got started at this smaller scale before we went to that. He takes these wood chips and puts them in these secondhand food service containers, stainless steel. He puts them on the bottom of his wood stove each night, has a fire on top of them, and then wakes up to fresh biochar in the morning. I want to point out, it's not required to have a kiln to make biochar. You can make it with piles. I'm working with several colleagues on this new method of piling, where we tore apart these piles, working with the Payette National Forest, and we reconfigured them by starting with this deck of logs that you're seeing, the heaviest fuels on the bottom, and sort of a corduroy that will protect the soils from the heat. We'll put all this smaller material on top light it, consider quenching it at the end. Still playing with learning how to do this. This is a sort of evolving technique, but it will protect the soil. Some of the piles I may have burned in the Flathead National Forest in the 1980s. My colleague Deb Dumrose from the U.S. Forest Service Rocky Mountain Research Station, she shows photos of where these piles were burned in the 1980s, and you can still see the holes in the vegetation from the extreme heat from those piles. So here's a way to sort of prevent that sort of thing. As I've mentioned, the simple kilns require less feedstock preparation costs, but the flip side of that is the biochar that comes out is much more crude, it's much more inconsistent piece size. This landowner wanted this material for a tree nursery that he was getting started there in Moab, and so he is crunching it down with the excavator bucket. It's a very friable or brittle material, so it can be broken into small pieces, and the smaller pieces will more readily incorporate into a soil, especially when it's sort of top applied, such as here. This is a little small box kiln operation in Soldier Summit, and in very heavy fuels we were operating in June or July, even almost the heat of summer, but operated quite safely. And we just use grain scoops at this scale to spread the char out onto the ground as best as we can, especially in landings, heavily impacted areas. And we find over time it'll work itself into the ground. We found coming into the job in the morning, sometimes you'll find deer eating the char, rolling in it, really interacting with it in surprising ways. Another application example from Idaho, just over the border north of me, near Snowville, Utah, is the Curlew National Grassland, part of the Caribou-Targhee National Forest. And here, just a few weeks ago, we applied this biochar as part of a restoration site. Turns out this is critical habitat for monarch butterflies, breeding habitat. Kind of who knew? But they have replace this creek or put it in a more appropriate place, and part of it is we're going to try to grow better habitat for the butterflies, or milkweed and forbs, using this biochar as part of the study. This is another project I work on. Is called Boa Goey, or this is the Bear River Massacre site in Preston, Idaho, on the Bear River, where we were making biochar. I'm working with a group of graduate students here, and this is in June. This is actually a red flag day, but I was allowed to burn, partly because I was so down the bottom of the valley next to a river, but partly because we're using these kilns. It really opens up that burning window a lot of times. Here we made char all morning from Russian olive. We have it quenched, and but turns out this char, I've had it characterized, and it's got a very high pH, like about 9.5, something like that. And so we're going to mix it with compost so that that settles that down. We can use it as a livestock amendment, a feed amendment, 2% diet amendment, and sheep actually prefer it. There's some rules against this I can't get into. We're allowed to do it for research purposes, but you can't do it in production methods just yet. In the Utah Botanical Center, we did a preliminary screening showing a significant increase in, like a 24% increase in productivity of tomatoes, and I think it was 4% increase in productivity of melon production with a biochar application. Here we're using it on mining sites in the Uinta Basin, an abandoned drilling pad, trying to grow something out in the Utah desert there. Here we're applying it under irrigation pivots. We tend not to recommend this. We didn't get a huge bang from our buck with this approach. We tend to recommend it more for high value agriculture than broad scale agriculture such as this. The city of Park City is using biochar as a key component of its attempt to get to carbon neutral by 2030. And one of the advisors, we're advised, I'm part of a team there in Park City with the sustainability group, and we're advised by people from Bloomberg Philanthropies and the Association of a couple of different associations. I'm not remembering all the names now, but we're fortunate to have grants and advice. And one of the teams that is advising us is the Stockholm Biochar project. And just to show you that this isn't just a Western or American thing, this is a worldwide sort of phenomenon. City of Stockholm has become a leader in biochar production and applications in urban settings. Coming up to my last slides. So I wanted to point out, this is essentially charcoal. And here I'm hosting some friends over for some grilled chicken with the charcoal was local juniper that we made in our big box kiln. So it's got another application. And of course, here in Utah, historically, we've been making charcoal for many hundreds of years, or a couple hundred years. These are beehive kilns just over the border in Wyoming, where they made charcoal for the steel and the iron industry back in closer to pioneer days. And ties into this very similar looking kiln. I was fortunate to give a presentation on this material at an international forestry conference in Brazil a couple of years ago, and ran into a fellow presenter who was talking about these types of kilns that they use in Brazil. And my colleague Hansu Pan from Northern Arizona University and I did a quick calculation and showed if we had these kilns, as many of them as they have in Brazil here in the United States, and we took all the fuel, all the hazardous fuels in all of California and all of Arizona, how long would it take to process all that material in this number of kilns? And the answer is just 1 year. So I just kind of show that as, it's not necessarily a practical example, but it just points out that it might be possible for us to actually get a handle on our hazardous fuel problems. A few helpful fact sheets on the one on the left I supplied just this morning to the WSU team running the winter school. Thank you very much. So that one is available to you. Actually, I have plans for the little kilns, the Oregon kilns. So any welder can produce those for $600 to $800 with the plans that are in that fact sheet on the left, and that is available, I think, on your website. Also, the Joint Fire Sciences program wrote this up in their success stories fact sheet series, the one in the middle, and then another one on using biochar for forest restoration. This is my contact information. I'd be happy to help you out, get you started on your own biochar adventures. Thank you for your attention.
Awesome. Thanks, Darren. I learned a lot. Honestly, I really know very little about biochar, so it's been this has been pretty awesome introduction to it. It seems like there's like a lot of potential for small forest owners.
It's mostly potential at this point, unfortunately, but we're trying to turn that into kinetic.
Well, yeah, that's how it starts. So we have about 10 minutes for questions, and we got quite a few, and they're still
Great.
coming in. So let's, some of these may have been answered at some point, but we'll go through all of them.
Okay.
So Sherry asked early on, what's the difference between gasification and pyrolysis? And I could probably use a refresher on the difference as well.
Yeah, thanks for asking. Temperature, essentially. Gasification happens at 800 degrees Celsius, pyrolysis at 400 to 600 degrees Celsius. Gasification, all the material turns into a gas, like propane, and a tiny bit of it turns into biochar. With pyrolysis, especially in high-tech machines, then we can separate thermochemical decomposition, separate out the bio oil. And at the time in 2014, we were more about the bio oil than the biochar, but it also produces syngas at that rate. I think that answers your question.
Yeah, I was saddened to hear that the price in oil, the change in the price in oil had that effect on, because they had a similar effect on like biomass, hybrid poplar markets as well.
But yesterday's newspaper said oil is up to $105 a barrel again now. And so I'll be encouraging John Webster from Go Biochar to reconsider the value of his oil. But that inconsistency sure makes it hard for small producers.
Well, and hopefully over time we're moving away from that kind of stuff and onto alternative products anyway. So, so let's see. Joe asked, for people weighing the cost to burn ratio between an ag stock tank and the Oregon kiln, what is the longevity of an ag tank?
I have not done multiple burns in an ag tank. They are lighter. They have that advantage. Assuming you're talking about just a simple tank like I showed, just a stock watering feed tank. I really don't know how much one of those tanks costs. I could guess at it, but I think I might have mentioned that the Oregon kilns, to have a welder build it, costs in the $800, $600 to $800 range. At least last time I had them built before. That was a couple of years since the price of steel has gone up so much to that. So I don't know if I don't really have enough information to accurately answer your question. I'm sorry. I hope that sort of dancing around gives you some background.
No, I think that's good. I recently purchased, I don't know what size tanks they were, but for dunking the mushroom logs.
Oh yeah.
Some stock tanks, and I'll say, they're a few $100s at least.
Yeah.
And the bigger you go, the more expensive they are. So it may actually be worth it to take the dive and get the actual kiln.
Yeah, and again, I mean, they're galvanized. At least for the first few burns, you're going to be burning off all that galvanized material. I don't know a lot about that, but especially if there's people around, it's going to make me uncomfortable. If it's out in the back 40 and you can just walk away first few times, it might be worth that.
Right. Approach. Yeah, exactly. So Ann Hayden asks, can you make biochar in a pit?
Yes, absolutely. I'm glad you asked. Thank you for bringing that up. Actually, the first time I made biochar, well, I don't know. I could argue the first time I made biochar was when I was gardening, when I was 9 years old in my backyard, but we won't go down that road. When I was a consultant in northern Idaho, I worked on one particular logging job in the winter where the landowner really wanted no fuels left, wanted a complete cleanup. And so we dug with machinery next to the landing, a great big pit. We got material going early in the winter, and all winter long, we just kept pushing it over. And it just consumed all the material. Our intention was not to make biochar. The word, I don't think, was invented yet. But it did make biochar, incidentally, and we buried it, and that was that. So the answer is yes, but the thing that makes me really nervous about that approach is people or animals can fall into a pit. And so the safety issues around pits make me really uncomfortable unless it's a highly controlled environment.
Yeah, that's a really good point. You'd at least want to put up some sort of guard.
Right.
Yeah. So we got another question from Sherry. So with the big box open system, is the syngas and bio oil that would be produced in a closed system consumed by the top fire? I don't know if I'm getting this question right, but
yes,
it isn't.
Yes.
Okay.
Yeah, all that material is consumed, all those volatiles. We would consider that bio oil and that syngas volatiles on the fuel. And with that high-tech machinery, electrostatic precipitators, we can separate that out and save that. But with big box, it's all kind of consumed in that flame cap. I did not mention that we have lids for the big box kilns, and some people use those for quenching, for snuffing. They call them snuffing lids. You have to sort of pack mud in around the edges, which is pretty labor intensive. So I haven't really gone down that road very much, but I really do like the lids as a safety device. If a big fire blows up, or you have a spot fire, or somebody calls you home to dinner, or whatever it is, you can just put a lid on it, walk away, and it will at least stall the process, and you won't have to worry about embers blowing around.
Nice. So what is the best way, if there is a best way, determined, of incorporating char into the soil in like a restoration setting or gardening?
So restoration setting, you're in the woods, so you're not going to want to disturb the soil. You're going to want to top apply it. And we find that, especially when the char is smaller diameter, like less than a 1/4 inch, then it only takes a year for it to work down into the soil with percolation and gravity. It actually moves around on the site over time that way, deeper down into the soil profile. In a garden setting, I recommend similar to what I was talking about in the Boa Goi project, where I almost never recommend people put raw char, especially in their garden. There's ways to use it in restoration for I don't want to get into those subtleties right now, but in a gardening setup, it's always best to charge it first. So mix it into your compost pile or mix it with 1-to-1 with manure and let it sit for a couple of weeks. Then it's charged. That gives the char an opportunity to soak up all those nutrients and then fill all those nooks and crannies with good stuff and make it available to plants. And then at that point, it depends on what ag. If it's alfalfa in year 3, you can't dig that up. So again, it's got to be top applied. But if it's corn, annual sort of a crop like that, then it can be mixed tilled into the soil.
Huh. And Brandon made a comment too that they've seen 30-gallon barrel systems or nested barrel systems, just using those traditional metal steel barrels that have burned through in about 10 uses, and imagines that the ag tanks would probably be something similar. I think that is an appropriate observation. And
I've done many dozens of burns in our Oregon kilns. I've yet to see one burn through yet.
Anne asked, are your kilns single walled or double walled?
So some are single walled. All the small kilns are single walled. My first big box kiln was single walled, and I've shifted to, and most of the sort of customers isn't the right word, but clientele, people that I work with, I generally recommend a double wall for big box kilns.
Well, we've just got 2 more questions and we're at the end, but I feel like we can just get through them if everyone's on board for that. If you're on board, stick around a little bit. What is the trade-off of open burning in a box on an increasing scale with regard to heat production and rising environmental temperatures? That's an interesting question.
It's a good point. I don't know all the ins and outs of that sort of. It would almost require a life cycle assessment. I've never seen one done about the heat. We tend to be more concerned about the smoke, and my perspective on that is all that carbon dioxide. If you leave that pile to not burn, then all that carbon dioxide goes in the air when it rots. If you burn the pile, all that carbon dioxide goes in the air when you burn it, and all that heat. If you make biochar out of it with one of these methods, then 1/3 of that carbon is preserved and not put in the atmosphere. So that's my point of view on that.
And then the last one here is kind of back to that, I think, dig a pit question. What about just a square box on top of soil? Would that work?
Yes.
Like an open bottom.
Open bottom. It would be similar to the Ring of Fire kilns. And you just got to dig in that bottom, and that absolutely would work. Ken Carloni, I mentioned earlier, he's got another system where he uses panels, which are lighter, and you can stack them up in the back of a pickup without having such a big thing. And they're interlocking panels that have no bottom, and that's his approach. And one advantage to that, at the end, you don't have to tip the whole thing. You open one of the side panels and you can just scoop the material out. So that can be a big advantage from some, if you have a limited amount of machinery or back power or whatever it is.
Yeah. Sounds like there's lots of creativity or room for creativity.
That's one of the fun parts.
Yeah. All right. Well, then we're at time. Thank you so much, Darren. And Darren has his email here. I assume it's okay to reach out to you there.
Absolutely. Please do.
But yeah, really appreciate it. I hope you have a good rest of your day.
Thank you. Appreciate it, Patrick. Take care, everybody.